Hello, welcome back to my channel. In today's video, we will discuss name-based classification. Let's start with the basics. Basic name-based is based on Bayes theorem, which help us update the probability of an event as we observe new data. What is name-based? Name-based is a probabilistic classifier based on Bayes' theorem, making predictions based on the probability of an event occurring given certain prior knowledge. Simple to implement. This algorithm is relatively easy to implement and understand even for individuals with limited machine learning experience. This algorithm is called naive because it assumes that all predictors are independent. For example, if we are classifying wines based on all alcohol and sugar content, name base assumes these features are unrelated with each class. This simplifies calculation. Underlying assumptions. Feature independence, probability distributions. Name base assumes that the features used for classification are independent of each other. This simplification is often an approximation, but it makes the algorithm computationally efficient. Second, probability distribution. The algorithm relies on probability distributions for each feature. These distributions are typically estimated from training data. While these assumption does not always hold true, name bias base still works surprisingly well in many cases. How name base work? Training phase. The algorithm learns from labeled data by calculating the probability of each feature value for different classes. Prediction phase. Given a new data point, the algorithm calculates the probability of the data point belonging to each class based on the learned probabilities from the training phase. Third, classification. The class with the highest probability is assigned as the predicted class for the new data point. Steps in name-based classification. Calculate. Calculate prior probabilities for each class. Estimate the probability of each class from the dataset. Calculate conditional probabilities for each predictor given the class. For each predictor given a class, calculate P xi upon y. Use Bayes theorem to compute posterior probabilities for each class. Assign the class with the highest posterior probability. Let's take an example. Wine classification. Classify wine as red or white based on alcohol and sugar content. Imagine we have a data set of wine. We want to classify each wine as either red or white based on its alcohol and sugar level. Here, here's the data: alcohol flag, sugar flag, or type. Alcohol flag high, sugar flag high, type white. Alcohol flag low, sugar flag high, type red. Alcohol flag high, sugar flag low, type red. Alcohol flag low, sugar flag low, type white. To predict the class for a new wine, we follow the step of naive Bayes. Naive Bayes. Dataset predict the variable alcohol flag and sugar flag. Target variable type. Contingency table create tables to calculate marginal and conditional probabilities. Apply Bayes theorem. Compute P. Type upon alcohol flag, comma, sugar flag. classifier assign the class with the highest posterior probability. Here, the formula which is used to identify the white, which is right or white. The formula is P type equals to red upon alcohol flag low, comma sugar flag low equals to P alcohol flag equals to low upon type equals to red into P sugar flag equals to low upon type equals to red into P type equals to red upon P alcohol flag equals to low, comma sugar flag equals to low. We can also see the code for this example. Advantages of naive Bayes. There are three major advantages: simplicity, efficiency, effectiveness. Simplicity. Naive Bayes is conceptually simple and easy to implement, making it a good starting point for machine learning tasks. Efficiency. The algorithm is computationally efficient, especially when handling large data sets, making it suitable for real-time application. Effectiveness. Despite its simplicity, Naive-Bayes perform surprisingly well in various classification tasks, especially in text and document classification. Application of Naive-Bayes. There are major amount of application of name-based theorem. Here we discuss only few. Spam filtering. Name-based is used to identify and filter spam emails based on the presence of certain words and patterns. Sentiment analysis. It can classify customer reviews and social media posts as positive, negative, or neutral, providing valuable insights into customer sentiment. Medical diagnosis. Name base is used in medical diagnosis to predict the likelihood of a patient having a specific disease based on their symptoms. Limitations and considerations. Feature dependency. The assumption of feature independence can be violated in real world data, leading to inaccurate predictions. Zero probability problem. If a feature value is not present in the training data, the algorithm may assign a zero probability, leading to incorrect predictions. Data quality. The performance of naive is highly dependent on the quality of the training data. Noise or inconsistencies in the data can negatively impact the algorithm's accuracy. This is the code for name-based classification. Here we import three libraries: pandas, SPD, numpy, snp, sklearn.namebase, import multinomial nb. Here creating the sample data set, alcohol flag, high, low, sugar flag, high, low, type white, red, white. Encoding categorical variables as dummy. pd.getDummies convert categorical variables into dummy or indicator variables. Train name based model equals to multinomial nb model dot fit x comma y. Multinomial NV create an instance of the name-based classifier. Model.fit x comma y trains the model using the dummy encoded predictors x and the target y. New data predict on new data. Create a new create a new data frame, new data with one record, PD dot data frame, alcohol flag, low, sugar flag, high, new x equals to PD dot get dummies, new data, convert the categorical value in, in new data into dummy variables. Align new x with the training data's dummy column. New x equals to new x dot reindex column x dot columns fill value 0. Predict the type. Prediction equals to model dot predict new x. Print predicted type comma prediction. Predict new x. Use the train model to predict the class of the new data. The new x now matches the structure of the training data. The prediction is stored in prediction variable. This is the code for naive-Bayes classification. Click on run button. This is the output. Prints the predicted class, which is red. Thank you. Don't forget to like, subscribe and share.